Okay, so we've turned the curve and we've now stepped into the hard stuff. Well, it's not hard, it's just long, sometimes tedious. So we read the paragraph talking about the great literary tradition of Great Britain, and we get to the point where Canadians feel they have a higher percentage of readers than uh, Great Britain, than the Britons. So a recent Gallup poll of 86% of 1,004 randomly sampled Canadians read at least one book in the past year. That was compared to 81% of 1,009 randomly sampled Britons. Do these results confirm a higher reading rate in Canada? And then it says test an appropriate hypothesis and state your conclusions. What it doesn't say is write the conditions. Folks, we've got to learn to write our conditions. So let's look at this and let's see what we can learn. So first thing we're going to look at is all of our information here. So I'm going to start out with, I'm going to say anything that has a B with it stands for Britons, and C stands for Canadians. We need to do this to be able to distinguish, to be able to put in contextual thought which one is which group we're comparing, because we have two groups here. Since we have two groups, we have twice the number of conditions. Okay, since we have two groups, we're going to have to write twice the number of conditions. So here we go. Let's look at first all the information we're going to come up with. And so we start with this. From our paragraph, we've got that the p hat for B, so B is Britons, is 0.81, which makes Q of that 0.19. And it told us that there were 1,009 randomly sampled. And so we then have to find our X sub B, how many Britons there were. So I'll multiply 0.81 times 1,009, and that's about 817 that read at least one book. Then we do the same thing with the Canadians. We have the p hat of Canadians. All right, and then we found the p hat for the Canadians, again from the paragraph, was 0.86, and so that makes Q hat 0.14. Their sample size was 1,004, so we took 86% of that and got 864 that read at least one book. Got to put context in there somewhere. We got an alpha of 0.05. Our null hypothesis can be written one of two ways. We can write the proportion of Britons equals the proportion of Canadians. Remember, this always has to be equal. Or we could say if we subtract the two, we're going to get the number 0, and that's fine. Either way, I will do this 90% of the time. This is way some textbooks and maybe on a test you might see. And that leads to the alternative, because it's said here the Canadians have a higher, and I put the Britons first, so the proportion of Britons is less than proportion of Canadians. Again, on the alternative, it could be that. So that's what we're looking at right now. Okay, and as I said, we're going to write twice the number of conditions, so here come our conditions. I wrote this as one sentence. It says they were both randomly sampled in the paragraph, so we write both groups randomly sampled. The next condition is the 10% condition, and so is 1,004 and 1,009. 1,004 is less than 10% of all Canadians. 1,009 is less than 10% of all Britons. So our sample size is small enough to help reduce bias. And then down here, to prove our sample size is large enough for our independence, we have to do two NPs and NQs for the Britons and the Canadians. So the Britons, we already know this is 817. So this number is going to be 193, both greater than or equal to 10. The same thing with the Canadians, 864 and 140. So our conditions are met to run a two proportion z-test. We have two groups, two samples. We're doing a two proportion z-test. Okay, so what I like to do, hello calculator. What I like to do next is go ahead and run the test to let me know what I'm looking for, what I'm working towards. So it's a two proportion z-test. So this is number 6. Got our numbers written in there. Oops, I got 818 there, 817. And I'll remind you that this always is whatever the alternative hypothesis was. It's a less than symbol. And so I calculate, and there's my numbers. Now I need you to notice we have a new number here. There's my z-score, which makes sense to us. There's my p-value, which is very small. small. I'm not going to call it very small. But we have this new p hat, and that's what we've got to find. To find p hat for the entire group, we take our two x's, the sum of our two x's divided by the sum of our two n's, and that equals 0.835. This is our new p hat, because that we need to find our standard error. So we take the square root of pq over n of the first group of the Britons plus PQ over the sum of the sample size of the Canadians. And that gives us our new standard error. Our new standard deviation is 0.017. These are on your formula page. When we assume that they were equal to each other, this is our equation after we found our p prime, our p hat, sorry. So now that we found that, we find our z-score, which is the difference of our two, which is 8.81 minus 0.86, minus their difference, which we assume to be 0, divided by their standard error, which we've said to be 0.017, and that equals a negative, as the calculator shows us, a negative 3.07. So the probability of our alternative hypothesis equals the probability of z being less than that number, which gives us this p-value, which again is on the calculator, 0.001059, so I rounded that up to 1 there. So here's our conclusion. With a low p-value compared to alpha, we reject the null hypothesis. There is evidence that more Canadians read a book this past year than Britons. And then we run the same test for a two-proportion confidence interval, which is going to be B. The two-prop Z interval, our numbers are already in there for us. It's a 99% confidence interval. We go through and calculate it. There's our new interval. So we are 99% confident that the true proportion of, the true proportion of Britons who read at least one book last year is between 9.3% and 0.8% lower than that of the Canadians. And that was simply that. Short video.